Alright guys, we are going to resume the test prep questions looking at the 26 to 33 section. We are using synthetic division to find the value of P of whatever the value is. Let's take a look at number 32. Excuse me. Now the difference between this synthetic division and then synthetic division we did up here is these, they give it to you as an expression and you have to then find the root, whereas down here they are already giving you the root, the 0. You just then need to do your magic with the synthetic division. Okay, so the first thing I'm going to do is put that 3 on the outside. And then I'm putting in my little box. Make sure everything is in order and that every term is represented. So then we have 2, 4, -10, and -9. As always, I bring my very first term down. Don't do anything with it. Then I multiply the first term by the number on the outside. So 3 times 2 is 6. 4 plus 6 is 10. 3 times 10 is 30. -10 plus 30 is 20. 3 times 20 is 60. -9 plus 60 is 51. And so my answer is 51. Alright, looking at the questions from 6-4, we have one question from factoring a sum or difference of cubes. We have one where we're solving a sum or difference of cubes. Then we have one where we're factoring the higher order polynomial, and in fact to the fourth, and then we have one where we're solving. So now let's go ahead and go back up and do one of each of these. I am going to begin by looking at number 14 because I believe 14 might be the most difficult as it has a factor in front of the x cubed. So the very first thing that I want to do is identify what is the cubic root of 125x cubed. And in this case, that would be 5x quantity cubed. And then minus the cubic root of 27 is 3. So that would be 3 cubed. Then I need to use my property, the difference of cubes, and what that states is the very first grouping is the first term and then the same sign as the original, minus, in this case, the second term, which is 3. Then in the next expression, we take this first term that we just put over here and square it. So 5x times 5x is 25x squared. Then we take the opposite sign, so that's going to be plus. We multiply the two terms together, so 5x times 3, and that is going to give you 15x. And then we we square the last term, so that will give you plus 9. And that would be your answer. Now looking at one of these problems to solve, let's take a look at number 19. Excuse me. So we're going to do the very same thing as we did above. It's a very similar process. Excuse me. We find the cubic root of our first term, which in this case is 2x. And we find the cubic root of our second term, which in this case is 1. So now I'm going to factor this using my difference of cubes. This is going to give me 2x minus 1 in my first group. And then in my second one, I square the first term. So we have 4x squared. I change the sign of the middle, multiply those two together, giving us 2x, and then square the last, which is 1. We now set each of these expressions equal to 0, which is 2x minus 1 equals 0, and 4x squared plus 2x plus 1 equals 0. This first one is easy because we are just solving it for x. So we're going to add 1 to both sides. So then 2x equals 1, and then divide both sides by 2. So then x equals 1/2. Right? I'm going to scroll there to get more room. And now for the second one, we need to use the quadratic formula. This 4 is a, the b is going to be 2, and the c is going to be 1. So then we have x equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which in this case is 4, times c, which is 1, all over 2 times 4. Underneath the radical, you have 4 minus 16, which is going to give you a square root of negative 12. And then we have the negative 2, and 2 times 4 is 8. So right now I'm going to simplify this. Rewrite it, I should say. And then I want to see if I can reduce the square root of negative 12. Well, the square root of negative 12 is the same as the square root of negative 4 times the square root of 3. Square root of negative 4 is the same as 2i. So now rewriting this again, we have negative 2 plus or minus 2i root 3 all over 8. Each of those have a like factor of 2, so this is going to give you negative 1 here. This is going to just give you the 1i, and then this is going to give you 4, resulting in negative 1 plus or minus I root 3 all over 4. Alright, so we have the three answers. We have the 1/2, and then we have the negative 1 plus or minus I root 3 over 4. Looking at our higher degree polynomials, we need to use our quadratic properties to actually factor the 21 through 26. Excuse me. And then for 27 through 32, we're going to set them up the same way, but then solve each of them for x. I'm going to select 24 to do as an example. So then 24 gives us x to the 4th minus 5x squared plus 4. We are going to substitute in a for x squared, which gives us a squared minus 5a plus 4. The factors of 4 that will give you negative 5 are going to be a minus 4 and a minus 1. I then replace my a's with x squared because there's nothing else that I can do here. So then we have x squared minus 4 and x squared minus 1. Now, these are both differences. They have the subtraction, and more specifically, they are difference of squares. So x squared minus 4 can be rewritten as x minus 2, x plus 2. X squared minus 1 can be written as x minus 1, x plus 1. And if you need to review this, this can be found in 5.4, and it was the last example of that chapter. Excuse me, of that section. Alright, so this would be the answer for number 24. That's it. Okay. Now for number, let's say, 31. Right. So we have x to the 4th plus 4x squared minus 12 equals 0. Alright, well, the first thing I'm going to do is what I did for number 24, and that is I am going to substitute in a for x squared so that I have a quadratic function that I can then factor. So for a equals x squared, that's going to give me a squared plus 4a minus 12 equals 0. This factors down to, I need factors of negative 12, that would give me 4. Well, I can do 6 and negative 2 because 6 times negative 2 is negative 12, and 6 plus negative 2 is 4. So then this gives me a plus 6 and a minus 2. There is nothing else that I can do here as far as factoring it, so I'm going to substitute x squared back in for a, giving us x squared plus 6, x squared minus 2 equals 0. Now in both of these cases I cannot factor that any further because neither of those are difference of squares. So I'm going to set each expression equal to 0 and then solve for x. So we have x squared plus 6 equals 0 and x squared minus 2 equals 0. I'm going to subtract 6 from both sides. We have x squared is negative 6. Take the square root. This is going to give me x equals plus or minus, because when you take the square root of a number, you have to have both options. And then the only thing I can factor out of there is the I, the negative 1, and that leaves me with the square root of 6. For x squared minus 2, we're going to add 2 to both sides, giving you x squared is 2. Take the square root of both sides here, and we end up with x equals plus or minus square root of 2. So this one has the 4 answers, plus or minus I root 6, and plus or minus square root 2. Alright, let's go ahead and get to 6.5 and finish this up. We have 2 questions from 1 through 6, and one is going to be where you list just your possible roots. The other one is going to be where you actually test them and find them. And then 13 through 18 is finding the roots of the polynomial equation, where you are going to be given one of those roots and then you have to use synthetic division to find the remaining roots and possibly the quadratic formula. And then 13 through 18 is where you find your conjugates. And then 19 through 24 is when you put it into the polynomial, or you put it into the form and expand it. Alright, so now let's take a look at 1 through 6. I've got enough time on this video to do number 3, and then we'll finish up with the third one. So looking at number 3, we want to find possible roots, and that is going to be looking at your factors of 4. So that would be plus or minus 1, plus or minus 2, and then plus or minus 4, all over the factors of the leading coefficient, which in this case is just plus or minus 1. So our possible roots are plus or minus 1, plus or minus 2, plus or minus 4. In order to test them, we are going to test each of those numbers. So you have 1, negative 1, 2, negative 2, 4, and negative 4. So plugging 1 into this equation is going to give us 1 plus 1 plus 4 plus 4, which is 10. That is not 0, so that's not a root. Plugging in negative 1, we have negative 1 plus 1, that cancels. Negative 1 times 4 is negative 4, plus 4 is 0. So this gives us 0, so that is a root. Right? All right, now putting in 2. 2 cubed is 8, plus 2 squared is 4, so that's 12. Plus 4 times 2 is 8, so that's 20, plus 4. So that gives you 24. Not a root. Plugging in negative 2, you get negative 8, and I'm going to write this down so that I don't mess up. You have negative 8 plus 4, and then 4 times negative 2 is also negative 8. And then negative 2, and then we have just plus 4. So you have negative 8 plus 4 minus 8 plus 4, and that is going to give you negative 8. So not a 0. Plugging in